So now we're going to see how we can relate luminosity with the mass and how they depend on each other. So we're going to do this in two different parts. First, we're going to figure this out in Math World. So Math World.
Then we're going to do Computer World, right?
Right. And then Chris is going to do Computer World.
Yep.
So let's start out by what we have in the code, or like what we know. So we know that the luminosity of the star, in our case in the code, we said that that was going to equal 1, which was the luminosity of the sun. So we have 1 times luminosity of the sun. But writing out sun seems a little bit tedious, doesn't it?
Yep.
So there's actually a really cool symbol we can use that we use in astronomy. Instead of writing out sun, we can actually use a circle and a dot in the center. And that represents the sun.
It's pretty.
It is pretty. And it's just like back in the other video we did, Earth was a circle with a cross in the center. So now we know 2 astronomy symbols in
All
this
the
video.
cool kids are doing it.
Yep.
So there you go.
Okay, so in the code, right, we had the luminosity of the star was going to equal to 1 times the luminosity of the sun, meaning it's just the luminosity of the sun. But this is only for main sequence stars. So there's this diagram called the Hertzsprung-Russell diagram, where it shows all the different types of stars. And only for the stars that are on the main sequence, we will have the specific relation that I'm about to write that relates luminosity and mass. So instead of writing 1, I'm going to relate the luminosity of a star with its mass. And it's going to be related by the mass of the star divided by the mass of the sun. And I'm going to put all of this to the 4th power. And then since we have mass and mass as a ratio, we know that this is going to be unitless, so we need a unit. And we had mentioned before that the luminosity is going to be in terms of units of the luminosity of the sun. So we're just going to add this to the end.
Yep. So, in reality, the mass of the star is, a gazillion kilograms. It's like, what is it, 2 times 10 to the 30 kilograms or something for
It's huge.
So instead of having to deal with those huge numbers, we can just divide that by the mass of the sun. And so now we have something that is a little bit easier to deal with. So for example, in the code, we're going to deal with stars that go from 0.25 times the mass of the sun, so a quarter of the mass of the sun, up to twice the mass of the sun.
Right.
So I think this is a bit easier to deal with than just using the straight numbers there. But we should double check that it works for the sun. So the sun is a main sequence star. Right?
Correct.
And so this equation is true of main sequence stars. So let's see if the sun actually works with this thing.
So let's write it out here. So for the sun, we have the luminosity of the sun. I'm just going to call it a star because we're going to pretend it's a star well, it is a star, but we're going to pretend it's just any star right now. Times, we said that the mass is going to be equal to the mass of the sun. So I'm just going to write this. It's now the mass of the sun. Divided by, and just pulling this back in, mass of the sun to the 4th power times the luminosity of the sun. And we can see that this, right, they cancel out. So we end up with 1 to the 4th power times the luminosity of the sun. And if I'm not mistaken, 1 to the 4th power is...
It's 1 times 1 times 1 times 1.
I think it's 1.
Yeah.
So we have 1 So we have that the luminosity of the star is 1 times the luminosity of the sun if the mass is equal to the mass of the sun, which is what we had up here. So we know that it is correct.
It works, yeah.
It works.
Works for the sun.
Works for the sun. So now, what would happen if the mass is actually twice the mass of the sun? So let's call this, I don't know, star with twice the mass of sun. So I'm going to write this equation down here, and I have luminosity of this star, but the mass is twice that of the sun. So on top, on the numerator, I'm going to write twice the mass of the sun, and then we know at the bottom in the denominator, we just have m sun, and this is to the 4th power, and then copying that, for it to have a unit, we have the luminosity of the sun. So again, these two cancel out because they're on the numerator and on the denominator. And we're going to have 2 to the 4th power times the luminosity of the sun. And 2 to the 4th power is...
So it'd be 2 squared times 2 squared, right?
Right, we can write this out as 2 squared times 2 squared times the luminosity of the sun. And we know that 2 squared is 4.
So 4 times 4. Carefully don't go below the screen there, Danielle. You're getting mighty close.
I'll go over here. So I have 4 times 4 luminosity of the sun. And we all know that 4 times 4 is?
16.
16. So we have 16 times luminosity of the sun. So the luminosity of the star that has twice the mass of the sun is 16 times more luminous than the sun.
So what do you think that's going to do to our star field? Is it
What
going to be a big effect, or do you think it's going to be a small effect?
I think that might be a pretty big effect, because now we're going to have pretty bright stars if their mass is big, in this case like twice the mass of the sun. And we're also going to get dim stars if the mass is about the mass of the sun.
Yeah, I mean, we'll have to find out.
We will have to find out, I'm guessing over here.
But, well, let's to put it in the code, well, we got to think about computer world, right?
Mm-hmm.
So now that we understand the math world here, so I'm going to cross out the math. No more math. We're going to do computers time. Computer world. And so this is going to change a little bit with the computer world. Maybe we can switch places here.
Yes.
So in computer world, this variable, do you remember the name of this variable in the program?
That in the program is called luminosity.
Yeah, so luminosity in the program. I believe in the program it's all lowercase, right? And then, so in the program, this is luminosity, but this is, we're setting it equal to 1. So in the program, instead, we wouldn't write it like this, we'd write it like this. We'd just get rid of this thing, right? Because I know that this is in units of solar luminosity, and you know that this is in units of solar luminosities.
So you know this is in units of solar luminosity.
Right, so we're going to change this to that. And so we don't need this in here anymore. And this equation, again, this is still equal to this variable luminosity. And so if this is that same variable, and we don't need it here either, right?
Mm-hmm.
Okay, so we got rid of that. And then in the program, we have a mass in there, but it's not like kilograms or whatever. So in the program, we've defined, we have this mass m. So we're going to randomly generate the mass of the star here.
Mm-hmm.
And so we're kind of, in the program, we're basically defining this to be the mass of the star divided by the mass of the sun. We don't really say that, it's not really built into the code of the program, but in the comments we say that this is in solar mass units.
Mm-hmm.
And so now I know that this is the mass of the star divided by the mass of the sun. You know that this is the mass of the star divided by the mass of the sun.
That means you know that's the mass of a star over the mass of a sun.
Right, so I can simplify this formula now, right? Or at least in the code. Like here at Math World is Math World, but in the code, I can write this as, again, L star just equals, again, so if this is equal to that, I can rewrite this just as m to the 4th. Okay? So this stuff is all true, but it's all Math World. And now, but in Computer World, the mass of the star goes, 0.25 to 2 or whatever it is. And all we got to do is take m to the 4th power to figure out what this luminosity is
Right.
in the units. So we just got to put this into the code. You ready?
I'm ready. Let's
All right,
go do that.
Do it.